This recording is extension. So if you haven't looked at the extension from the previous unit about the graph of the tangent function, please do that first because this is about transforming that tangent function. So let's take first a look at plain old y equals tangent x. Now I've also put in dashed lines here to represent the vertical asymptotes. The tangent graph is just the blue. The dashed orange is not part of the graph. We're just seeing where those vertical asymptotes are. So here's what tangent looks like. Notice that it repeats more often than sine and cosine do, more frequently. It has a shorter period. Specifically, it has a period just of 1 pi instead of 2 pi. So the period of tangent x is 1 pi. That's going to come into account here as we look at our period calculations. It's very similar to sine and cosine, except instead of 2 pi in your numerator, you've got just 1 pi in your numerator. Another important difference is that the tangent graph, because it doesn't have a highest or lowest point, there is no maximum or minimum, it goes up forever, down forever. There's no amplitude number. So tangent graphs do not have amplitude. And when you're calculating periods, start with a pi in the numerator instead of a 2 pi in the numerator. Phase shift and vertical shift, those work the exact same way as they did with sine and cosine. So here's what you're going to be asked to do. We're going to describe in words what the transformations are, and then identify period, phase shift, and vertical shift. To start off with, you do need to do that same factoring thing with the parentheses that we did with the sines and cosines. So take here the inside parentheses. This is really 1/3 times theta plus 7 pi over 4. We're going to rewrite this as 1/3 times parentheses theta plus. Now, when you divide a 1/3 away, that's the same as multiplying by 3. So this ends up being 21 pi over 4. So I'm going to rewrite here in black, y equals 8, tangent, parentheses, 1/3, parentheses, theta plus 21 pi over 4 plus 4. All right, when you're describing this, you do need to start with what function you begin with. So we start with the tangent function. Right. Then let's talk about stretching and compressing. So first, the vertical stretch or the horizontal stretch, it doesn't really matter what you do. Because we have an 8, that's going to be in front of everything. That's a vertical stretch by a factor of 8. So stretch vertically by a factor of 8. For the horizontal stretch or shrink, 1/3. Now that number is less than 1, and horizontally that means you're lengthening your period. So there's a horizontal stretch as well by a factor of 3. When they got that 1/3 in there, that actually makes things 3 times as long. Now let's talk about shifts. Then shift 21 pi over 4, and that's going to be, it's a plus, so that'll be to the which way? To the left. So then shift 21 pi over 4 left and 4 units up. Okay, so we've described the transformations. Now let's answer the questions about period, vertical shift, and phase shift. So for period, start with a 1 pi this time, divided by the absolute value of b. That's going to end up being 3 pi. For your vertical shift, that's up 4. We've already described that in words. And for your phase shift, that's going to be to the left by 21 pi over 4. Now, just so we can see the journey, let's see how this all plays out when we do, in fact, transform our tangent graph. So I'm going to leave the blue and the orange up there. And we're going to now graph our transformation. So starting with y equals tangent x, we're going to stretch it vertically by a factor of 8. And this is going to make it look almost kind of like a straight line. to see what's going on, I'm going to change our viewing window so we see higher and lower. So I'm going to go down to like -30 and up to +30. And even here, now you can kind of see how the red graph isn't a straight line. It's got that tangenty sort of shape to it, but it's taking its time. When we're stretching it out vertically, it's going up real fast and down real fast. So I think I'm going to change the window one more time. Let's even go down to like -80, +80. So now you can kind of see how in red it looks like more like a tangent graph. So that's our vertical stretch. Next, let's lengthen the period. So notice now in red, it's taking a lot longer to go through one complete cycle. So it actually takes, if we go from 0 up to 3 pi, notice we've got the red going up, vertical asymptote, the red going up. That's how long it takes for it to go through one cycle. Now let's do our shifting. So plus 21 pi over 4. So we've shifted everything 21 pi over 4 to the left and put the +4 on the back. There we go. So in blue is your original tangent graph. In red is our stretched and shifted transformed tangent graph. So same general shape, it's just got a different level of curvature because of how it's been stretched and moved around. All right, let's go again. I would like you to try this one on your own. Do a quick pause, unpause when you're ready to check things. Let's look inside the parentheses. So 4 parentheses theta, that means I'm dividing by 4. That's the same as multiplying by 1 over 4, which is going to make this a pi over 12. So as far as our equation goes, how about y equals 1/9 tangent 4 parentheses theta plus pi over 12 minus 1. All right, let's describe things. Once again, we start with a tangent function. Then we got a 1/9 in front of everything this time. So we are going to shrink or compress by a factor of 1/9. So everything's getting smaller by that 1/9 multiplier. Now notice that inside our b value is 4. That's going to shorten the period. So we're going to go through these tangent cycles really quickly. So we're also going to compress horizontally by a factor of 4. Now for our shifts, our phase shift, it's going to be to the left pi over 12. And down by 1. There you go. Those are your transformations. In describing the period, let's now address those numbers here. So for your period, start with pi. That's the period of regular tangent. Divide by the absolute value of b. You should end up with pi over 4. Phase shift, we already discussed. It's left by pi over 12. And the vertical shift, we also already discussed. It's down by 1. Let's see how this plays itself out in our transformation. So again, I want to start with a regular old tangent graph. Let's put in our compression vertically. So notice how the red graph stays closer to the x-axis for longer. That's because these large values get shrunk down. These large negative values get shrunk back up. Let's shorten our period. So look at this. We now have 4 times as many of these little tangent curves happening because the period got shortened by a factor of 4. Let's put in our plus pi over, and it was 12, right? So our phase shifted pi over 12 left. So everything moved to the side a little bit. And then a minus 1 on the end. So in blue was tangent that we started with. And in red is our compressed, shifted, and shifted tangent function. So with these transformations, you can make these graphs go where you need them to and do what you need them to, which is what makes those transformations so powerful. The big takeaway, it's really just like sine and cosine, except there's no amplitude. And when you're doing your period calculation, start with a 1 pi on the top instead of a 2 pi on the top.